Welcome back to Element 14 Presents. I'm Lorraine, and this week I'm going to hack a Lego train. So this is a Lego train, and it runs on kind of standard Lego tracks, and it's Bluetooth controlled. So I don't know where the controller is, but it has like a controller that makes it go forward and makes it stop, and it follows the track, and the track has some curves in it, and I love it. It's really cool. I love the control, like that's fantastic. And of course, being a computer scientist, straight away I was like, oh, I wonder if we can hack this. So we want to make it go to our own commands, maybe make it go like every hour the train moves, which would be really cool. But to do that, we need a track. So where are we going to put this track in my house? Can't really put it on the ground. It'll just be in the way, kind of on a shelf somewhere. You know, you don't want to be really bumping into a shelf, kind of at shoulder height. The basement's already full with a laser cutter and a 3D printer. So what we're going to do is we're going to put it up onto the ceiling. So this is the sitting room, so let me show where we're talking about. Here's the door, and if we go up, so the reason we can do this is because we've got nice tall ceilings. So this is the main wall that's going to go across. You notice this like curved wall, and then onto the window, which still has Christmas decorations, even though it's March. So I'm standing on the sofa. So the train can't really go around this wall because it's just too curved, and it just wouldn't be any point because it ends at the curtain there. So this is going to be our start point. So we're going to add a shelf, probably about there. And that's where the train's going to travel, and it's going to travel that way. To here, and it's going to turn. So it's going to turn this corner here, and then keep going to over there, to here. So we're going to stop here because there's an alcove here, so there's no point in turning again because it's really short. And then we've got another curved wall and a big clock there that I don't really want to move. So that's it. It's just going to cover two walls. So let's look at some of the equipment that we got for this. So this is the Lego track that came with the train. We need 8 meters of this. So we need to decide how we're going to do this. We're going to laser cut it, we're going to 3D print it, or do we need track at all? Will it just stay on the shelf? So that's problem number one. What we also have is the XIAO. I love how it comes in the little box, and then a little padded box, and then a plastic bag. Feels like I'm going to open a ring. But that's the XIAO that we're using as our main controller. We got the battery and the battery holder. Hopefully this is all going to fit in the main carriage, in the main train and the carriages along. Because those carriages have windows, we're obviously going to add some multicolored LEDs. This is the Bluetooth controller. So we're not going to use this. We're actually going to hack the Bluetooth signal. Which someone's already done, so that's great. One problem we do have, which is what this is for, is power. We don't want the train to be constantly on 24/7. So we kind of want to turn off the battery for the train. And the only way you do that at the moment is through a switch. So one idea is to actually just have this little servo turn on the switch when needed. So we're powering the XIAO through these batteries, and the train has a separate battery. So this is to turn off and on the train battery. So we're going to mount this on top of the train so we can see when the walls are coming. And this is the wood. Okay, let's set up the XIAO then. So we're going to do this in CircuitPython. So here is the CircuitPython page for the XIAO. I've got the XIAO Sense, so I'm going to download that now. To get the XIAO into bootloader mode, you press reset twice. Can you see where reset is? So yeah, it's this teeny tiny button just here. So we've got to press that twice to get it into reset mode, and then download the UF2 onto there. Then I'm going to use Thonny to program everything. So you'll see it comes up on the COM and it's CircuitPython. So to get it to actually show, you need to press stop, bizarrely, and here's some code. So I've been playing around with the NeoPixel code. I got this demo from here. So this is the Adafruit page. It's for one of their drivers, but basically I downloaded the project bundle here. So it gave me this code, and also in the lib, this one here, the neopixel.mpy. So it's like the library. Then, this is like a magical mystery tour. I wanted to see what the actual name of the pins were. So this is the seed page, and this is them. So I'm going to use D10 because it's right next to 3 volts and ground, which is what we're going to need for our pixel strip. So that's what we're going to start with. We're going to start with the RGB LED strip, because I feel that's the easiest one to get started. And then we're going to add the LIDAR. So you can see the XIAO is labeled, and they're my cables. So these are male to female jumper wires going into my NeoPixel strip. And I'm going to plug that back in and see if the code will just work. And it did. For some reason I thought I had to press play or something. Can you see that? Oh, you can see it. Hey! That's a bit better, isn't it? So I just, in the code, it was only 12 LEDs, which is why it doesn't look, why the whole strip isn't lit up. And I put it into code.py, which runs automatically. Well, that was nice and easy. Let's see if the LIDAR is going to be just as easy. The LIDAR white is TX, yellow is PWM, which is any pin really. And then we have red is ground, and blue is 5 volts. So I've wired up these onto the board. I'll do a little diagram of the final setup. What I had to do with this breadboard was split out ground, because there's only one ground on the XIAO. So I have to share it between the NeoPixel and the LIDAR. So when we plug it in, the LIDAR starts spinning, which is very exciting. So let's see what the code looks like for that. So I found this code here, which again is Python, not quite CircuitPython. So it's got like NumPy and it's got matplotlib, which we don't want to do. We don't want to like plot this in a 3D graph or anything, or any kind of graph. And it uses like a state machine to keep track of everything. So I took this code and I made some amendments. The one major thing was obviously reading the serial a bit different, and their measurements, they kind of create a load of measurements because they're going to plot it, while I really only want to see one measurement. Is I'm going to take the angle between 85 and 95 and just print out what that measurement is, print out the first value of the measurement, which should be the distance between my hand and the LIDAR. So let's run this code and see what kind of numbers we're getting. Okay, so we lose some connections, but that's okay. So we're getting between 2,000 and 200. That's a bit weird. Now, the trick is to find whereabouts. Okay, now that I've moved things around, we're getting between 400 and 600. 400 and 1,000. So where is 95 degrees? Let's start sticking my hand in places. So it's not there. Oop, it's not there. It's not there. Aha! So you can see those really small numbers. That means this is the angle, 85 to 95. So when we set this in the train, we need to do this test again and work out which way is forward, so we can see the wall coming, and we can slow the train down. So that's perfect. So we think the best idea is to test this on the ground or the dining room table before testing it on the ceiling. So you can't tell, but we've cleared the dining room table. Barak door is up there. It's a great spot for it, I think. And we've set up the train track, but it's too curved. I need to add some straight tracks in here. And we need to start adding the circuit of the XIAO, the NeoPixel strip, and the LIDAR to the train and its carriages. So this is the train, and there are 2 carriages to it. So what I want to do is put the NeoPixel strip in the carriages, so up against the windows, and I think it's just about long enough to kind of wrap around the 2 carriages, which would be really cool. And then the LIDAR is going to go on top here of the first carriage. So we're going to take off the roof, just like that, and start feeding the NeoPixel strip in there. And then we're going to take off the back door, not this back door, this back door, to get the cable to go through there. So we need to blow the doors off. So you can see the NeoPixels there. There they are, through the open doors. I think I might try and stick them though, because this one back here keeps kind of moving. So maybe some tape or something to make sure that they stay in the window. Maybe some Lego. But I'm actually really happy with how that looks. That's going to look awesome lit up. So that's it. Ha ha! So we have the train with the NeoPixels in the side, the LIDAR. Obviously, we don't want this in the final thing, so we need to get it running on battery. Bit worried about how much the LIDAR sucks out of the batteries. And it stops, it recognizes walls. So this is our handy wall here, and it stopped at that one. And then, can you see the other one? Yep. And I'm really happy with that. So we can only do so much testing on the ground. I think the next test is battery, and I don't know about the servo. That's another kind of, the servo is to save power, but it might actually waste some of our power that we have for the XIAO. So the servo was going to go on here and push the train battery off to save the train battery power. But I'm worried about the XIAO battery power and how much we have there. Given this LIDAR, I think it's taking up a lot of power. We've kind of overkill with the LIDAR. You're like, do we need LIDAR? We could have just used like an ultrasonic sensor, but it does look cool spinning on top here. So, well, we would need 2 ultrasonic though, one pointing that way and one pointing that way. LIDAR is the best. It was the best idea. So I think it's time to do a battery test and then put it on the ceiling. I want to do one more test, like a longer test of the track before it goes in the air. Ooh. Oh my god, I didn't think it was gonna stop on the corner there. That was a very nice dunk. Oh, that corner's, oh, like a slower corner. Nice. The neighbours started mowing their lawn. People tractor rally in town. We're going to film this shot. Phil's gonna drive. Oh, that was so good until it wasn't.
Yep. It's okay.
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 Oh my god! The clunk is not good.
Yeah.
Alright, come on, get past the corner! Yes! Stop, 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 stop! Oh, beautiful. Why have you stopped there?
I don't know. That's okay.
And there we go. I really enjoyed making this project. Let me know your feedback on the Element 14 website. On there you'll see some extra footage, some bloopers, the shopping list that you'll need to make your own train, and the code that's running on this train. I'll be there to answer any questions. Until next time.